Assalamu alaikum everyone. Today we have to continue with this chapter number 10, and we will try to see that how we can compare different investment alternatives and which alternatives or the machineries they can give us more interest and they can have better process feasibility. So let's see what we have. When comparing mutually exclusive investment alternatives, choose the alternative with the greatest positive net present value. Okay, so we have to choose the project which can give us the greatest net present value, and for the net present value we have studied in chapter number 9 also, and also in this chapter, that the projects that have the higher net present value, they can offer more rate on return on investment, and they can have the higher interest rate also. Okay, because when you put the net present value equal to 0 and try to calculate the rate on return on investment, then it would give you the maximum value of the interest. Okay, so with the projects having larger net present value, the rate of return from those projects would be also higher. Now let us see what are the different steps and the algorithm that we need to see or to compare different investment alternatives. So algorithm for incremental investment analysis. So number one, establish the minimum acceptable rate of return on investment for such projects. So basically, whenever we make any project, we try to set some rate of return, that this one is the minimum rate of return that we should get from a certain project. Number two, calculate the net present value of each of the project using the interest rate from step number one. So we have done this step number two earlier also. So we try to calculate the net present value of the project at the end of the project, and then we try to see what is the interest rate that we can get from that net present value. Okay. Then step number three, eliminate all projects with a negative net present value. So when you make the analysis on different projects and you try to calculate the net present value of each of the projects, so we can ignore those projects that have the negative net present values. Okay, so we are focusing towards the projects that have the higher net present value, that can give you the higher rate on return on investment. Step number four, of the remaining projects, select the project with the highest net present value. Okay, so the last step, whatever the projects you have made in the analysis, you have to go with the project that offer the highest net present value. Now today, let's see one more example here. The concept of the risk here. So there is a businessman or the vice president, and he was provided with two options. Now let us see those options one by one. A new product is to be produced which has never been made in the large scale. So the first option, there is a new product, and it has to be the first time, which is never produced earlier. Pilot plant tests have been made and products sent to the potential customers. So the pilot plant analysis and the tests were performed and sent to the customers. The calculated rate of return is 33%. Okay, so the anticipated rate of return, it is 33% for this option. Now for the second option, a second plant is to be built in another region to meet the increasing demand. So there is no new product, but for the same product, we need an additional plant into some another region. Company has a dominant market position for this product, and already the company is manufacturing that product. The rate on return on investment is around 12%. So you can see here the rate of return is 33, but here in this case it will be 12%. Now which option should we go with, or the company will go with? Now let us see what is the concept of risk here. So the items that favor option 1, high rate on the investment. First of all, we can have the higher rate of return. Opens a new product possibilities, and also this one is a new product, so maybe the possibilities of getting the higher market attraction, it is very high. Okay. Now the items that favor option number 2, well established market. So already there is a market which is well established, and the sales are up to the level. Well known manufacturing cost, we know that what is the manufacturing cost of that product. Transportation cost will be less, and the transportation cost for that particular product will be less. Already the transportation network is there, okay, and the mature technology. We don't need to test anything new, and the technology is already there. We just need to put a new plant. Now, the high rate of return of option 1 is associated with the high risk. So, what we see in the option number 1, the rate of return, it is very high, but it is associated with a lot of risk. Okay, VP's decision, consider the option 2 due to the concern of lost market position. So, the VP, he go with the option number 2 due to these factors, because they don't want to lose the market share. If they don't put a plant into the new region, maybe some competitor would make a plant there, and that would take the market share. Okay, so from the investment point of view, you cannot lose the market share. Okay, so if the market share is high, your sales will be increased. Okay, so the VP go with the option 2 due to the concern for the loss in the market position. And now let us see evaluation of the equipment alternative. So if we are having different equipments, so we have to consider that which equipment we need to have for our project. Okay, so there are three main methods that we can use to analyze the equipment alternatives. So the factors to consider: capital cost of the equipment. First of all, we are interested in the capital cost. The second thing, we are interested in the operating cost of the equipment, and the third thing, it is the lifetime of the equipment. Okay, so these are the three factors that we need to consider when we compare different equipments as an alternatives. Okay, the equipment with the same expected operating life. So there are two basic ideas. First one, the equipment with the same expected operating life, and there could be a situation in the equipments where the expected operating life is different. Okay, so the first analysis we will do with the same expected operating lives. Okay, so when operating cost and equipment lives are the same, so operating cost and the life of the equipment is same, obviously we can go with an option which is less expensive one, the lower capital cost one. Okay, so we can choose some equipment that offer the less capital cost. Okay, when capital cost and the operating costs are different, but operating lives are same. Okay, so capital cost and operating cost is different, but the operating lives are same. Then what we have to do? We have to do the net present value analysis, and we have to choose the alternative that offer the least negative net present value or the higher net present value. Okay, now let us see this example, and that would give you more like a detail about about the equipment with the same expected operating life. Okay, so in the final design of the stage of the project, the question has arisen as to whether to use the water-cooled exchanger or an air-cooled exchanger in the overhead condenser loop of the distillation tower. The information available on the two pieces of the equipment is given below. So there are two alternatives. Either we can go with an air-cooled heat exchanger, or we can go with the water-cooled heat exchanger. The initial investment is given 23,000 for the air-cooled, and the operating cost is $1,200 per year. For the water-cooled, the initial investment is low, $12,000, and the operating yearly cost is $3,300. Both equipments, both pieces of the equipment have service life of 12 years. So we can see that the equipment life is same for both the cases. For an internal rate of return of 8% per annum, what piece of equipment represents the better choice? So we have specified the internal rate of return to be 8%, and we want to see that which equipment is a better choice and that can save more money, and that will make the project more feasible. Okay, so we have to do the net present value analysis for each of the equipment, and we will try to see what is the net present value for each of these equipments. Now, to get the net present value analysis, we know what is an initial investment, and we know what is the yearly operating cost. So we can use the equation which can relate the present values and the annuity. Okay, so we can maybe use this equation. Okay, we are provided with the annuity or the operating cost annually, and we want to calculate the present value. So the equation that is here, 1 plus I with the power n minus 1 divided by I 1 plus I with the power n. So we can use this equation in our analysis to get the present value for the operating cost. Okay, so the same thing we have done here. So we can start with this one. The net present value, it is the initial investment that we made, so that will make minus 23,000. And then we have to include the operating cost, and we have to find out the present value of the operating cost. So operating cost, we are spending money, like the money that we spend for the initial investment. So we have to use the negative sign here. So minus 23,000 minus 1200 operating cost, or we can call this one as an annuity now. Okay, so 1200 will be the annuity, and if we simply use this equation, 1200 multiplied by 1 plus I, interest rate is 8%, so 1.08 with the power 12 years, so that is operating life minus 1 divided by the interest rate, which is 8%, 0.08 here, multiply by 1.08 with the power 12 years. Okay, so this way we can have the operating life for this particular equipment. Okay, so we can add this one, minus 23,000 minus whatever the factor or the present value that we get here, that will give you the value for the air cooled heat exchanger, that will come out to be minus 32,040. The same way we have to do the analysis for the water cooled heat exchanger. So the minus sign with this initial investment, then you will use the same equation for the annuity here, and this time you have to multiply this one with the operating cost, that is or the annuity that we see here, 3300. Okay, and the rest of the things you have to use with the interest rate and this equation. So you can all add these two terms together, and it will give you the net present value for the water cooled heat exchanger, that is minus 36,870 dollars. Okay, so from here what we see from the analysis, the air cooled heat exchanger is the better choice. So we have to choose the equipment that will give you the least net present value, least negative net present value, or like the higher net present value. So here it is the least negative net present value for the air cooled, so which is the better choice in our analysis. Okay, now let us see the equipment with the different expected operating life. Now if we are dealing with the equipments that have the different expected operating lives, then we can consider three methods to make the choice between different alternatives. So the first method, it is the capitalized cost method. The second one, equivalent annual operating cost method, and the third one, it is the common denominator method. So the effect of inflation is not considered in the above methods. In all of the three methods, we ignore the effect of inflation. All the methods consider both the capital and the operating cost. So when we make the analysis, all of them will include the capital and the operating cost, and minimizing the expenses, and we will try to see what is the net present value of the project, and that would give you some reasonable analysis on the profits. Okay, if you are getting the higher value for the net present value, we can go with that option. Okay, whatever alternative or the option for these three methods you use, it will give you the same analysis, and the final outcome of the analysis, it will be the same. So let us see this one in detail here. So the first method, which is the capitalized cost method. So in the capitalized cost method, in this method we establish a fund for which a piece of equipment that we wish to compare. This fund provides the amount of cash that we need to purchase the equipment initially, to replace it at the end of its life, and to continue replacing forever. Okay, so let us see these three things together. So in this method, for example, we want to buy some, maybe a heat exchanger. So the cost of that heat exchanger would be equipment cost P, and there is some additional amount that we will keep aside, which is called as a residual cost. Okay, so what we do in this analysis, we spare some fund from the project, and we invest that fund into some bank, or we keep that fund separate into some other investment. Okay, so whatever profit we get from that investment, from that interest, we will buy the equipment, and this is how we can continue the changing of that equipment. Okay, so for example, here you invest some money into some project, and from that return, you initially bought some heat exchanger or some equipment. Okay, now the residual amount, which is also kept aside, you will invest this money into the bank or some other project, and from that money, after say like 5 years, you would generate enough interest that you can buy the new equipment again, which is a replacement. Okay, so after 5 years, with the same interest amount, you would buy a new equipment without spending any extra money. Now again, you invest the residual money into the bank, for example, and after 5 years, it will generate some money. And after 5 years, you are able to replace the equipment again. Okay, so this one is the capitalized cost method, in which you spare some fund from the project and you invest it into the bank or uh, some other project from where you can generate some interest, and from that interest you can keep on buying the equipment and keep on replacing the equipment over the lifetime of the project. Okay, so this is called as the capitalized cost method. Now for this method, you would see two equations. First of one, which is the capitalized cost, and which represent you the cost of the equipment. So P is the equipment cost and R is the residual amount, and this is an equation you can use. So the final version of this equation for the capitalized cost, it is P, that is the cost of equipment, and with this factor 1 plus I is interest rate, and equivalent is the expected life of the equipment. Okay, and the same way. Okay, so if you want to simply calculate the capitalized cost, you can use this equation, but we know that we also need to calculate the running cost or the operating cost. So we have to calculate the equivalent capitalized cost, that will be the summation of capitalized cost that would be coming from here, and then we have to add the capitalized operating cost of the equipment also. Okay, so we can add these two things together, and the final equation that we will get here, it will be in this form. So P represent you the cost of equipment, I is the interest rate, N is the operating life of the equipment, YOC is the yearly operating cost, and then F by A, this one is basically if you want to calculate the final value based on the annuity, then you have to use this equation. So maybe you have to use F by A equation, this equation here. Okay, so annuity, it represent you the running cost, and then you can use this equation to get the final value. Okay, so and the rest of the thing, and the denominator 1 plus I with the power n eq minus 1. So neq is the operating life, I is the interest rate. Okay, so let us solve one example with this methodology, capitalized cost method. Now, example 10.7. During the design of the new project, we are faced with the decision regarding which type of pump we should use for the corrosive service. Our options are as follows. So, carbon steel pump, capitalized cost is 8,000, operating cost per year it is 1,800, and the equipment lifetime is 4 years, and after 4 years you have to replace this one. The second option, stainless steel pump, capital cost is high, 16,000, almost double. Operating cost less than the carbon steel pump, 1,600, and the equipment life, it is 7 years. So we have to see that which alternative we can choose. Okay. Now, what we have to do, assume a discount rate of 8% per annum. So the discount rate that is already mentioned in the example, it is 8%. And now we have to calculate what is the capitalized cost. Okay, so for the capitalized cost, you have to simply go back to this equation, equipment at capitalized cost, P into 1 plus I with the power NQ. So principal amount is mentioned there, which is 8,000, then 1 plus I, 1.08 with the power 4. So operating life is 4 years for this pump. 1,800 is the operating cost, 1 plus I, 1.08 with the power 4 minus 1 divided by interest rate, and divide by 1.08 with the power 4 minus 1. Okay, so we are just following this equation here to get the value for the equivalent capitalized cost. Okay, so for this pump, carbon steel pump, the capitalized cost that we calculated here, it is 52,700. Now the same thing we will do with the capitalized cost estimation for the stainless steel pump. Okay, and we find out the value for this stainless steel pump to be 58,400. Now from this analysis, what we see here, the capitalized cost of the carbon steel pump, it is less than the stainless steel pump. So because the carbon steel pump has the lower capitalized cost, it is recommended. So from this analysis, what we see here, the capitalized cost of the carbon steel pump is less, so we can go with this alternative because it can save more money. Okay. Now let us say the second method, for comparing the alternative, which is the equivalent annual operating cost EAOC method. The capital cost of the equipment is spread out over the operating life to establish a yearly cost. So what we see here, for example, you buy some equipment with the price P, and these are the yearly operating cost until the lifetime of that equipment. Okay, and what we do here, we actually remove this equipment cost and we try to distribute this cost over the yearly operating cost. So the yearly operating cost would be increased, but we will not consider the equipment cost now. Okay, so this way we can see here EOC, which represent you the equivalent annual operating cost, that will also include the some amount of the capital cost or the equipment cost. Okay, so we can do this analysis, and here you can actually see the equation for estimating the equivalent annual operating cost. We have to use this equation, A by P. Okay, so A by P, you can go with this graph here. So this one is the part for A by P. If you are having the what is the principal amount, and then you can actually calculate what is an annuity for your equipment. Okay, so this equation we can use to get the value for the annuities over the lifetime of this equipment. Okay, and then you have to add with this one the yearly operating cost. So let us solve one example for this particular problem. Okay, now compare the stainless steel and the carbon steel pumps in the earlier example 10.7 using the equation for the equivalent annual operating cost method. Okay, now for the carbon steel method, what you have to do this one. You have to calculate the principal amount, right? And how you would do this thing. Sorry, you have to calculate the annuity here by this equation. Okay, so the equation that we are gonna use here, it is this equation, and what you would find, so P multiplied by this amount by the formula that we get here, I with the multiply by 1 plus I with the power n divided by 1 plus I with the power n minus 1. Okay, so here we have the same thing. We multiply the P, which is the cost of the equipment, 8,000, then we multiply with the interest rate I, and then we multiply this one 1 plus I with the power 4, so that makes 1.08 with the power 4, and then we have to divide it with the 1 plus I, which is 1.08 with the power 4 minus 1, and then we have to add the operating cost with this equipment. Okay, so the information, it is already given here. So the yearly operating cost, it is basically given here. The capital cost, it is also given here, and we now use the same data but with the different methodology. We calculate the equivalent annual operating cost, which is the $44,220 per year, and for the stainless steel, the cost, it will come out to be $4,670 per year. So from this analysis, from the equivalent annual operating cost method, we see that the alternative one, which is the carbon steel pump, it is more beneficial and it can save more money. Okay, so in this example also, the carbon steel pump, it has been evaluated as the better option compared to stainless steel pump, and also in the capitalized cost method, we have seen that the carbon steel pump, it is more beneficial in terms of investment compared to the stainless steel pump. Now let us see the last methodology, which is the common denominator method. Now for this particular methodology, what we have to see, there are two equipments, equipment A and there is an equipment B. So let's say for the equipment A, the lifetime is n years, and we can replace this equipment for the m times. Okay, so every year, so n is the lifetime. Okay, and then you can replace it for the m. You have to do the m replacement. Okay, so you can again replace this one, that will make 2n, and then you can keep on continue, and at the end you can have the m replacements that will make this one m multiplied by n at the end. Okay, so the same or the thing we have to do with the equipment B. For the equipment B, you can have the different operating life. Okay, so the operating life is m year, but for this one we need to have the n replacement. Okay, so we have to first replace this one m, then you can keep on doing this one, and at the end you can have the n replacement, so that will make the mn at the end of the project. Okay, so for both of these equipments, we make the denominator same. we for this one we also make mn, and for here we also make mn. Now here you can see it can be replaced 1 2 3, maybe 4 or so on, and now here it will replace 1 2 and 3 times. Okay, so that will like the baseline, it will remain same in terms of number of years now, but the replacements these are the different. Okay, so we will see that how we can use this methodology to get the feasibility between choosing the alternatives. Okay, now compare the two pumps so that are given in the example 10.7. So we have to use the same example and we will use this methodology using the common denominator method. The discrete cash flow diagrams for two pumps are shown in the example. These are the discrete cash flow diagrams. The minimum time over which the comparison can be made is 4 into 7. So the total time it is 28 years. Okay, so this one it has been replaced 7 times. So the carbon steel pump, we say that for the lifetime is 4 years, and we can replace this one for 7 times, which is basically the operating life of the stainless steel pump. So we can multiply these two numbers together, so the total time for analysis it will become 28 years. Okay, so this one 1 2 3 4 5 6 7. Okay, so 7 replacements for this carbon steel pump after every 4 years. Okay, so the same thing we have to do this one. So this one, the lifetime of the stainless steel pump, it is 7 years, and for this one we have to replace this one 4 times over the timeline of 28 years. Okay, so for these methodologies we have to keep the denominator of the lifetime of the project to be same. That's why we are multiplying n with them. Okay, so the total time it is for 28 years, and now we have to see which alternative is better for our investment. Okay, now for this kind of analysis we have to calculate the net present value for the carbon steel pump, and we have to estimate the net present value for the stainless steel pump. So how you would do this thing? So first of all, for the net present value assessment, you have to include the investment that is required for the equipment, and then you have to see what is the running cost of that equipment. Okay, now to get the net present value of that carbon steel pump, we have to use a simple equation P by F. Okay, so we can use simply this equation where you have the value for the F final value, and we will get the value for the P here, the net present value, because we are trying to calculate the net present value. So the value that you have here, it is the final value. Okay, so you can multiply the F on the right hand side with the 1 with the divide by 1 plus I with the factor n. Okay, power n. Okay, so you can see this one for the first year you can have 8,000. 8,000 multiplied by 1 divided by 1 plus I with the power n. So n here it will be 0 for the first year. Okay, so for the first year you can only return maybe 8,000. Okay, and for the replacement after the 4 years, okay, now if you are doing the replacement after the 4 years, now the value for n it will be 4 in this example. Okay, so that will make minus 8,000. Again, f value is 8,000. You can multiply on the right hand side 1 divided by 1 plus I. Now the value for n that you have to choose, it is 4, because you are doing the replacement after every 4 years. So the same way you have to continue this thing until you reach the year 24, because this is the last year where you have made the replacement. Okay, so if you look at this one, minus 8,000, here they have taken the common, and then you can add these terms together. So for the first year it is 0, for after 4 years it is minus 4. You are bringing the denominator into the numerator here. Okay, and same way you have to do it for the until the year 24. Okay, now this is the analysis for the equipment, and now you have to do the analysis for the operating cost. Okay, also. Okay, so for this thing you have to use the equation. The annuity is given here, which is 1800, which is the operating cost, and you have to estimate the present value. So you have to simply use this equation, P divided by A. So for this one, P divided by A, that is this equation. So you can multiply the annuity on the right hand side, and you can solve the equation to get the present value for the operating cost. Okay, so it will be the factor here. Now you can add all of these things together to get the total value for the net present value, that will be equal to minus $46,580. Okay, so the same thing you have to do it with the stainless steel pump. Okay, and for the stainless steel pump, the value that you have evaluated here, it is minus $51,643. Now from the analysis of the net present value, what we see here, the equipment which has the least negative net present value, that is the better option. So here from this example, the net present value for the carbon steel pump, it is the least negative value in comparison with the stainless steel pump. So we see this one, the carbon steel pump has a less negative net present value and it is recommended. Okay, so what we see overall from these examples, that either we go with the capitalized cost method or the equivalent annual operating cost method, or either we can go with the common denominator method. The final analysis that we do, it will give you the same result, that we have to go with the carbon steel pump. Okay, so with this example, we have finished the chapter number 10, and that's all. Okay, so let me know if you don't understand anything.